So this is the part 2 of Dijkstra's algorithm, and in this video we will actually see the Dijkstra's algorithm in act. We will see some examples and see the internal implementation of the algo. But before that, I want to say that graphs can be of two types in terms of edges. It can be directed as it is seen in the picture. So you can go from A to B, but not vice versa. And in the second type of graphs, which is undirected, you can go from A to B and from B to A. And for Dijkstra's algorithm, it doesn't matter if it's directed or undirected because it does not deal with the directions, but rather it deals with the weights of the graph, which are these small little numbers above the or close to the edges. And also I need to mention that Dijkstra cannot work with graphs which has with with graphs which have negative weights. So for example, if we're instead of 1 we have -1, Dijkstra will fail to work. That's why we need to consider only the weights which are positive. And the main difference between BFS and Dijkstra is BFS meaning breadth first search, is that BFS finds the shortest paths in terms of the number of nodes between the source and the destination node. But in Dijkstra, the shortest path will be the one which has less weight among all. And Dijkstra, we use Dijkstra to find the shortest path from single source to every other node, but we can also use it to find the shortest path between two nodes. We just need to stop the program once we reach the final destination. And we will use the same example as in the textbook of the course, and we will have some annotations. Maybe this video will be a bit longer than 5 minutes. Okay, the first thing we're gonna do is we will write all the edges that we have, all the nodes we have, C, D, E, F. And for A, we will write on the right side, we will write all the nodes that are connected to A. So the first is gonna be B, and near we'll write the weight. And that's gonna be D with weight 3, E with weight 3 as well, and so on for each node. So here C is empty because it doesn't have any edges, and F is empty because these edges, no, because these edges were already considered here and here. Okay, and the next step is we will make a table. So here we have two notations, d-value and p-value. D-value denotes the cost, while p-value just denotes the parent of the node. So here we can get to B from A, so that's why A is the parent of B. And the column in the middle is for the priority queue. So Dijkstra uses priority queue, basically minimum priority queue. It puts the nodes in regard to their weights. So the minimum will always be in the topmost priority. So in this case, in this case, the source node itself will be here because the distance from A to A is 0. And then we'll go the next nodes with minimum weight. So in the very, very beginning, uh, all of the nodes will have a weight of infinity, and you'll find out later why. And the source node's weight will be 0, as I mentioned earlier, and the parent will be null for every node in the very beginning. And later on, we will make some updates on them. So we look at this table and we see that the minimum weight is 0. So we put that node into the expanded vertex column. That's gonna be A with weight 0. And the next we will find all the nodes that are connected to A. So in this case, it's B, D, and E. So let's write their weights here. So the weight of edge between A and B is 1. So we update the negative, the infinity by 1. And we see that E, the weight between A and E is 3. So we write 3 here, and the same for D. We write C3. As for the parents, we will update these 3 nodes parents to A. So B's parent will be A, D's parent will be A, and E's parent will be A. As for the rest, they will remain as infinity, and this will remain as null. And in the next step, we will choose the minimum from here. So we see that B has the weight of 1, so we choose B as the top with topmost priority, and we do the same. So we find all the nodes, that's E and F. So for E, so from B to E, so we had weight of 1, and then we have weight of 1. So if we add up, that's gonna be 2 from B to E. And for F, it's gonna be 1 plus 3, which is 4. And we will update E and F's parents to B. And the rest we will just let empty. And for this, we don't have any other better option, so we'll just put it here. Yeah. And for C, we still do not have any edges going out, and that's basically it. And with the same, we choose the node with minimum weight, and in this case, it's E with weight 2. And if you look here, we see only F, so we have 3 and 2 and